Lesson 5.3, Graphing Radical Equations. So let's graph some radical equations. Let's start with the basic graphs. We have y equals the square root of x. If we graph that, we have a point at 0, 0, point at 1, 1, and a point at 4, 2, and looks like that. Notice it starts at 0, 0, so our domain is x is greater than or equal to 0, and our range is y is greater than or equal to 0. Because it starts here, goes that way in the x, that way in the y. If we do cube roots, though, and we make a table, we can actually do -1, -1, the cube root of -1 is -1, 0, 0, 1, 1, but we also have -8, -2, and we have +8, +2. So when I draw my graph, see it extend through those points. Because it goes left and right and keeps going up and down, our domain and range are both all real numbers. You need to know the shapes of each graph. Right, you've had this before, how graphs transform with A, B, X, and H. A, remember, is a vertical stretch by a factor of A. B is a horizontal shrink by a factor of 1 over B. So remember, it's inside the group, so it's opposite. If A is negative, it's a reflection over the x-axis. If B is negative, it's a reflection over the y-axis. H translates to the right, but notice it's minus H, so it's backwards. And K translates up. But in general, how are we going to graph radical equations? We're going to use our calculator to make a table of values. And for our first example, I'm going to give you some functions, and I want you to describe the transformations. All right, so I see a +2 there. So that means H is -2, because it's the same as minus a -2. And it appears like K is a -3. So what kind of transformations is that? So that is a translate. Since it's a -2 in the H, it would be left 2. And since the -3 in the K, it would be down 3. So we're going left 2 and down 3. And there's the graph. So this is the original square root. Everything went left 2 and down 3. That point went left 2, down 3. This point went left 2 and down 3. Let's try another one. All right, what do we notice? Oh, I see the negative. What's the negative mean? Well, the negative means, oh, it's on the outside, so that means it's a reflection over the x-axis. And then it's multiplied by 2. But that's inside, so that's horizontal. So that makes it a horizontal. And remember, it's backwards. So this will actually make it a shrink by 1/2. 1 over the B. So it's a reflection over the x-axis. That means it's flipped upside down, and it shrunk sideways by 1/2. And that is our graph. The dotted one's the original. The solid one is the transformed. Let's say the function e of d is 0.25 square root of d. It's the number of seconds it takes a dropped object to fall d feet on Earth. The function jd is 0.63 times e of d, approximates the number of seconds it takes a dropped object to fall d feet on Jupiter. How long does it take a dropped object to fall 81 feet on Jupiter? Well, we want j of 81, which is 0.63 times e of d, but d is 81. Wait, that is the stuff there. So e of 81 is 0.25 times the square root of 81. Square root of 81 is 9, so 0.25 times 9 is 2.25. So I could substitute that in here. All of that is the 0.25. Multiply that by the 0.63, and we end up with 1.42. And it said this was measured in seconds. All right, let G be a horizontal stretch by a factor of 3. It's a horizontal stretch, and so that means it's on the inside, and inside is always backwards. So that means our B is going to be, instead of 3, it'll be 1 over 3. So it'll be the reciprocal. Okay, so that means we'd have cube root of 1/3 x. All right, that's the first thing. Followed by a translation of 6 units right. All right, 6 units right means that our h is going to be 6. All right, so that is going inside with the x. So it's going to be right in as most joined to the x as possible. And remember, it's x minus h. So it'll be that way. Why did I put it in parentheses? Because it came second, and it's with the x, so it has to be tied directly to the x. Then we can simplify. It'll be 1/3 x minus, see, 1/3 times 6 is 2. So make sure you do the first thing first, and then the second thing second. And if it says, if it's horizontal, it's always tied directly to the x with parentheses. Did you know parabolas could be sideways? Well, did you notice that the square root looked like half of a sideways parabola? So we can graph horizontal parabolas and circles by solving the equation for y. And then we can create a table of values. And then we can plot the points and draw a graph. So let's graph -1/5 y squared equals x. So I'm going to solve this first of all for y. That's our problem. So the first thing to get rid of is this -1/5, so I'll multiply by a -5. And then I need to get rid of the square, so I need a square root. If you're solving an equation, you square root, you have to remember the plus and minus. So now we need to make a table So let's make a table. My table, I have, it might be a whole bunch of points. So -6 is 5.48. -5 is 5, and don't forget these are plus and minus. Negative 4 is plus and minus 4.47. Now, in my calculator, I could only put in the positive or the negative, but if I put in the positive and then I just put the plus and minus in front of it, so why do we have these errors? Oh, because I can't take square roots in negative numbers. So when x is 1, I'd be trying to take the square root of a negative 5. Well, we can't exactly do that. So we're going to graph this. It looks like a square root. It's reflected over the y-axis. That's the negative there. And it's going to be shrunk by a factor horizontally of 1/5. So negative 6 is about there and there. Don't forget it's a plus and minus. Negative 5 is there and there. Negative 4, 4.47, plus and minus. Negative 3 is 3.87. Don't forget plus and minus. Negative 2 is 3.16. Negative 1 is 2.24. And then 0 is 0. So we have this graph looks like that. Notice it is a sideways parabola. Notice also that this part, just the top part, looks like a square root that's been reflected over the y-axis and horizontally shrunk, just like our equation or function looks. All right, let's try this one. X squared plus y squared equals 49. Since they're both squared, this actually gives us a circle. But let's just go ahead and solve it for y and then make a table of values. So I'll have the original problem, solve it for y. Solve y squared equals 49 minus x squared. Then I'll have to square root. When I'm solving, the square root, don't forget the plus and minus. No, that is not 7 minus x. We learned in the last lesson that if it was multiplied, we could split it up, but it's not multiplied, it's subtracted. We cannot split this up. So now at this point, we're going to make a table. So put it in my calculator. Negative 7 is 0. Plus and minus 0 if you'd like. We have the plus and minus. We have plus and minus. Now you do not need to write out, sorry, that was a 7. You do not need to write out your table. So 6.92. And I think we'll notice that it becomes symmetrical, because that's what we would expect with a circle. And so on. We can use our symmetry from there. Now my little graph only goes out to 6, so I'm going to put my 7 there. Don't forget they're all plus and minus. 4.9, 5.74, 6.3, 6.7, 6.9, and 7. And then 6.9, 6.7, 6.3, 5.74. I'm using the symmetry that I had. 4.9, 3.6, and then way out at the edge, which I don't have on my current paper. So you can see this makes a circle. The radius of 7. Look at that. The square root of 49 is 7. So our radius was 7.